Hey guys, this is Test 42 Game 1. This is the Scientists panel game. It's an in-out game, also known as selection, and I've laid out a bunch of stuff here, but don't worry, I'm going to explain all that. They tell us that we've got 5 scientists in, so I've laid out 5 slots here, and there are a total of 9, so 4 must be out. We have the botanists, FGH, chemists, KLM, zoologists, PQR. They tell us that there must be at least one scientist from each type, so I've got a botanist slot, a chemist slot, and a zoologist slot, and then 2 others that we don't know what they will be, and everyone else is forced out as a result. Now they tell us that if we have more than one botanist, we have at most one zoologist. Now, of course, we have to have at least one zoologist according to the first rule, so when they say have at most one zoologist, they're really just saying have one, not allowing for the possibility of 0. 0 is actually impossible because of the first rule. So if we have 2 botanists, we would have 1 zoologist, leading us to have 2 chemists as a result to reach our total of 5 in. If we have 3 botanists, we have 1 zoologist, therefore we will have only 1 chemist to reach our total of 5. Then we have a lot of conditional rules. They tell us that F and K can't both be in, meaning that if F is in, then we have K out. Contrapositive, if K is in, then F must be out. Also, K and M cannot both be in, so if M is in, then we lose K, and if K is in, then we lose M. So if M is in, P and R will both be in, and if either P or R is out, then M will have to be out. Now, I know this is a lot of arrows here. That's basically just what the rules are telling us. If either M or F or M is in, K is out. If M is in, P and R will both be in. If K is in, F and M are both out. And if either P or R is out, then M will be out. So a lot of arrows. I know it's a lot to look at, but that's basically just exactly what the rules are telling us and nothing more. So the first question of the game is a typical orientation question. Just take one rule at a time, apply it to all 5 choices looking for violations. So we could take the rule that K and M cannot both be in together, second to last rule of the game, because it's easy to look for. Scan through the choices. You find that both B and D include both K and M. That's unacceptable, violating this rule, so that's gone. We could look for the rule that F and K cannot both be in right over here. The third rule of the game, scan through the choices. Choice A has both F and K, unacceptable, so that's gone. Next, we could look for the rule that M in requires both P and R to be out. M in requires P and R to both be in. Scan through the remaining choices. We find that choice E has M, yet also has P, unacceptable. E is gone, leaving C by process of elimination for number 1. Next, number 2, if M is the only chemist chosen, then we automatically know that the other chemists, K and L, will have to be out as a result. We also know that M in requires P and R to be in, and so of course one of those, it will be the zoologist, meeting our minimum requirement for zoologists. The other one, R, will simply be in one of our random slots. And then of course, because we have more than one zoologist, we cannot have either 3 or 2 botanists due to the contrapositive right here of our second rule of the game. Therefore, we will have only 1 botanist, one of F, G, or H, and the other 2 of those guys will have to go out. So I'm putting F/G/H in the botanist slot, forcing the other 2 botanists, whoever they might be, to go in the remaining out slots. So this leaves Q forced to go in just because there's no other place for it to go. Now they're asking us what must be true. Must we have both F and G? No. At least 2 botanists will be out, so we will always lose at least one of F or G. A is gone. Must we have both G and H? Again, we're only going to have 1 botanist, the other 2 have to go out, so B is gone. H and P both chosen. P has to be in, but H could be out, so for that reason C is gone. Must we have all of F, G, and H? Of course not. We're only going to have 1 botanist, the other 2 are forced out, so D is gone, leaving E by elimination. And then of course if you look, you see that we have all of P, Q, and R in. That must be the case. Next, number 3, if we have F, L, Q, R as 4 of our scientists. So F is a botanist, L is a chemist, one of Q or R will meet our minimum requirement in terms of zoologists, and the other one of those 2 can simply go on one of the random slots right here. Now we know that F in requires K out. So for that reason, we can automatically put K in our out right here. Now, we are having multiple zoologists here, both Q and R, activating the contrapositive of the second rule of the game. Therefore, we will have only one botanist, F, and then G and H will be forced to go in our out slots. Now, M in would require both P and R to be in due to the rule right down here. However, we only have room for, 2 out of M, P, and R. Therefore, if we had M, we wouldn't have enough room to have P as we must. Therefore, M must go out and P is forced in. So we are actually able to determine every single slot for this scenario. So they're asking us who must be fifth. Of course, P will be the fifth one after F, L, Q, and R. So E is our answer to number 3. Next, number 4. If P is the only zoologist selected, we know that automatically Q and R would have to go out. Now, we cannot have M in because R out requires M out. So we're going to put that in the out column as well. Now, we haven't placed either of F or K, and we know they conflict. Therefore, the remaining slot in the out column must be occupied by F/K. One of those guys will go in. We don't know which one. So our remaining people for the in column will be one of K or F, as well as any remaining variables, meaning F, G, H, and then L. So we can put G in the botanist slot right here. We can put H in one of the random slots. We can put L in our chemist slot. And then this right here, we don't know exactly what it will be. It could be K, it could be F. So I can put K/F in the remaining slot right here. And this is almost fully determined in terms of our layout. Now they're asking us what must be true. If K is in, G cannot be in. No, we could easily have both K and G, so for that reason A is gone. L and F conflict. No, we could have L here and then F there. That would work out fine. So for that reason, B is gone. If one chemist is chosen, it must be K. Of course, we already have L that has to be in, so C is gone. If we have 2 chemists, F cannot be chosen. Well, if we have 2 chemists, those 2 chemists would be L and K, because we have to have M out. So then there'd be no room for F. So for that reason, D is a must and is our answer for number 4. I'll look at E though. If 2 chemists are chosen, G cannot be in. Of course, G absolutely must be in, so E is gone, leaving D if you didn't get it before. Next, number 5. If we have both G and H in, so one of those will satisfy our minimums regarding botanists, the other one will go in one of our random in slots, and if we have 2 botanists, or maybe even 3, we will have only 1 zoologist, and then not all 3 chemists. So for that reason, 1 zoologist, only one of them will be in our in column, so I'm placing that in our zoologists minimum number 1 slot, and then the other 2 of those guys, whoever they might be, will have to go in our out column. Now we know that M in would require P and R to both be in. Of course, that's impossible to satisfy here, so for that reason, M will have to go out. Now we also know that F and K conflict, so we're going to have one of those guys in and one of them out. So I'm just going to put K/F under the in column because we don't know exactly where it's going to go. We do know that we're not going to have M in, so our chemist here will have to be either K or L in, and we don't know exactly what's happening remaining, but we have L left to place in and we have K/F to place in. So we've determined almost everything here. Now they're asking us, what must the panel include? Well, we know it's not going to include M, so if you look at choices B, C, and D, which all mention M, you can automatically cross off that portion of the choice, leaving B, C, and D to say F, K, and Q. Now, there's no particular reason to believe that we need any of F, K, or Q in particular. So for that reason, B, C, and D are automatically eliminated, leaving A and E. Now, looking at E, P or else Q, we could easily lack both P and Q in the out column, and then have R as our sole zoologist. That would work fine. So for that reason, E is gone, leaving A as our answer. And then if you look at choice A, of course, we must have one of F or K because only one of those two will be out. The other one will have to be in the in column. So for that reason, A is our answer to number 5.